Finishing up this lecture on the types of natural selection, we discussed that natural selection is very much a cause of evolution in addition to genetic drift and gene flow. Natural selection, we have discussed at the beginning of the lecture, hitting up Darwin and his theory of evolution and how the 4 criteria are involved for natural selection to occur. That has to do with passing genes to offspring, having a selection pressure or competition between individuals for food and resources. In addition, making that individual having a higher evolutionary fitness. This is reproductive success, the ability to adapt to the current environment. All these things are natural selection. There are different types of natural selection. So I'm actually going to use this graph right here. Let me go over it before we hit up the 3 different types of natural selection that I'm going to discuss. Here on the y-axis, we have frequency of individuals. So the higher you're up on this axis, the more likely, the higher number is going to be shown, the more likely you are to have that type of phenotype. Phenotype is here on the x-axis. It looks like I have fur color showing you guys a phenotype. I have white to a light gray, gray, a darker gray, all the way to a black phenotype. And I can see here in this graph, already off the bat, there's a distribution of these phenotypes. It seems like we have one extreme over here, that white color, that's an extreme, to the other side of that scale, that black dark color, that's another extreme. And we don't have too many individuals at the extreme level, but kind of getting an intermediate between those extremes. So a lighter gray to a darker gray to a gray, we actually have the highest number of individuals with that phenotype color. So I kind of see that nice bell curve going on with the phenotypes and the frequency of individuals with that phenotype. The first type of natural selection that you're going to see is seeing this graph stay the same shape, but shifting over to one side. This is called directional selection. The graph is going to shift over to either the right side of that intermediate or the left side. I'm showing a right side shift in this image. So the dashed line here is showing you the original frequency, so that intermediate phenotype being favored. Well, that's the original population. Well, with evolution and natural selection occurring, it looks like there's a selection pressure to choose those darker phenotype individuals. It looks like that white phenotype and that light gray no longer exists in this new population. It's evolved to favor those darker colors. This is called directional selection. It could also go the other way. It depends on what adaptation is playing into these individuals' favors here. So it's going to change the overall makeup of the population, and basically it's favoring variance at one extreme. Know that directional selection favors variance at one extreme. It's shifting over to one extreme side, whether that be the right side, those darker colors, or the left side, those lighter colors. It's going to a certain direction. The next type of natural selection is called disruptive selection, and it's called disruptive selection in that the original population is now altered. Let me get my pointer, and that now both extremes are favored. I can actually see a drastic change in that original shape of the graph, and now I have 2 sides that are favored at one time. That lighter white colored phenotype and that darker phenotype. This is called disruptive selection. It favors variance at opposite extremes over intermediate individuals. Those intermediate individuals, that kind of lighter gray, gray color, and a little bit of darker gray, are now no longer seen. We see now extremes being favored at the same time. Intermediates weren't favored in this type of natural selection. The last type of natural selection is called stabilizing selection. And you might have guessed it, now I have only intermediate phenotypes being favored. Those extremes have now been selected against, and we no longer see them in this new population. The intermediates will thrive. So it removes the extreme variance from the population. You can also say that it's going to prefer the intermediate phenotypes. I wanted to say something else here. Yes, These types of natural selection, any type of natural selection, whether you're directional, disruptive, or stabilizing, you are decreasing genetic variation in the population. So check it. In our original population, we had a distribution where we had many different variations of fur color. I had a white, light gray, gray, dark gray, black. They're all different types of fur color. Well, in directional selection, you're removing some of the lighter colors or maybe some of the darker colors. It depends where the graft is shifting, but you're removing some. In disruptive, you're getting rid of those intermediate phenotypes. In stabilizing, you're getting rid of the extreme phenotypes. You're decreasing genetic variation regardless. Natural selection definitely decreases genetic variation in any population. Whenever you have a selection pressure where you're favoring a certain gene, you're going to decrease genetic variation.